Welcome to today's webinar. The topic today is most frequently asked questions answered by Dlubal Support team. We present this webinar regularly. We show questions or answer questions that our customers send to the Dlubal Support team. That should be a help for you. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, the technical content of the website, German and English webinars, customer projects, newsletters, and so on. I will be the moderator today, and I also present a part of the webinar. The other part of the webinar will be presented by my colleague Stefan Hoffmann. He is the head of customer support. He prepared the questions and the presentation. And we will answer your questions when I present, then Stefan answers your question, and vice versa. Okay, you can ask questions by clicking that button. I switch off my camera that you can see the full screen. That button with the question mark, then you can enter the question here, press send, and we will receive your question. Okay, that should be all. I start the presentation in the program. The first question for today is, how do I set an uniaxial load transfer for a plate? In order to specify an uniaxial load transfer for a plate, you can assign orthotropic properties to the surface. We prepared 3 surfaces for today. That's a standard surface, and the others are, this one is an orthotropic thickness for isotropic material, and this surface has an orthotropic material model for constant thickness. Those are the 2 options to consider an uniaxial load transfer. So we have the same surfaces, the same loads to compare the results later. So let's double click on that surface. As I mentioned already, standard stiffness type, uniform thickness, and an isotropic material. So then let's double click on that surface where the stiffness type standard defined. The thickness is shape orthotropy, and the material is isotropic. Let's click the edit button for the thickness with material. Now you can see for the thickness type, the shape orthotropy was defined or selected. So let's go to this dialog where is entered 200 millimeters for the effective thickness for X direction. That should be the direction where the load transfer should be. And for the secondary direction, where it's defined a small value, you can't enter 0 here. It's not possible to calculate it. There are numerical problems. Important hint for the self-weight definition. There are different possibilities. You can be selected, determined from parameters. Then an average is calculated here. That's not what we want. And there are also user-defined self-weight, where you can enter the self-weight in kilogram per square meter. We use the middle option, the thickness 200 millimeters. Okay, then we can leave the dialog and select the plate on the right side. Stiffness type, standard, constant thickness, but we have defined a material of thickness, orthotropic. Let's take a look at it with the edit button. You can see that the orthotropic material model was defined and the user-defined material is checked. So let's go to this dialog, orthotropic linear elastic surface. And you can see that there are different moduluses of elasticity for the different directions. Now for a uniaxial load transfer, you need to change the modulus of elasticity of the secondary load direction by entering a very small value. You can also specify, or you need to specify a very small value for the shear moduli in the secondary support directions. And the Poisson's ratio can be set to 0. So let's leave dialog. So we calculate all. So, and you can see the different results. For example, the basic internal force, mx, where you can see for the orthotropic models, the highest value for mx in the middle of the plates. And there are very small support reactions for the secondary directions. For the standard plate, the highest values are on the longer sides, and for these models on the shorter side, the values are not 0, because of the FEM, but they are very small. My, you can see very small values, and that's the reason for the small support reactions. If I click on MXY, you can see where there's a high torsional stiffness for the standard surface, but not for the orthotropic surfaces. Okay, that should be all for the first question and the first model. We turn to the next model. The next question is, how can I quickly create a surface model from any cross section? Okay, that's a typical cross section that was imported from the library U200. Let's go to the edit button and the library. A hint, you can't create surface models from cross section, from massive cross sections, but for thin-walled, standardized, and so on, build up, where you can see that different surfaces should be possible for the flange and the web, and so on. So let's try it. With a right click, the context menu is opened, members, and then at the bottom generate surfaces from members. And then you can see the web is now a surface and also the flange. And the thickness of the flange is 11.5 millimeters. That's the average from the original member or original cross section. So, as I already mentioned, it's not possible to do it for such members. I double click on it anyway. That cross section was defined in our section. You can go directly to our section with that button. So let's go left above to the base data. You can see the analysis method, finite element analysis, is checked. And for those cross sections, it's not possible to create a surface model in RFEM, but for film weld analysis. That's the other example. We try it for this one anyway. Right click, members, and you can see the option is grayed out. So I double click on the member on the right side. Section, also a section that was created in our section. I press the button again to turn to our section. So I turn to the base data again, left above, and you can see thin weld analysis is checked. Okay, and also parts and elements must be defined. So, and then you can create a surface model. It's a quite new option. So right click, members, and generate surfaces from member. And now you can see it is divided, or it's if a surface model is created. Thickness 4 millimeters, geometry type plane. And for the roundings, let's double click on one. Thickness 4 millimeters, but the geometry type is quadrangle. Okay, that should be all for this question. We turn to the third question. The third question is, how can I elastic couple elements? There are different possibilities. For example, the line releases are possible, or line hinges. In the case where our members and surfaces are connected in one line, or they are connected in the same line. But for this example, I showed it on the wireframe model. We have two members without any eccentricity. The center of the member is in the middle of the member. This is a member of 1 meters width, and the thickness is 300 millimeters concrete, and the member below is a solid member of timber. This is valid for all three members. But there are defined different rigid links. That's the possibility that I would like to introduce. You can see the rigid links in the navigator data on the left side. There are 3 rigid links defined. To create a new rigid link, you can do a right click on it, then new rigid link. I double click on the first rigid link. Now you can see there's no line hinge defined. That means, the connection is absolutely rigid. So then I double click in the middle. So you can see a line hinge is created. I press the edit button. In longitudinal direction, in X direction, there is a very high spring constant. In the Y direction and around the X axis, there are small spring constants. Spring constants are created, that you can calculate the model that isn't unstable. So then we double click on that rigid link. Also a line hinge is created with a small spring constant in longitudinal direction. So let's take a look at the different results. Or I show again the load, the same load, and then the results. To display it a little bit better, I turn to the navigator results, and for the deformation, I check lines. You can see, I switch off the releases. You can see the different deformations. The smallest deformation is on the left side. For the rigid link without any line releases or line hinges. So quite or higher deformation for the rigid link with the line hinge with the high spring constant. I can see it again. And the highest deformation with the rigid link with the smaller spring constant in longitudinal direction. So let's take a look at the releases. The forces, the normal forces in the longitudinal direction, it's 0 for the rigid link. We've got quite high values for the rigid link with the higher spring constant and a very small value for the rigid link with the smaller spring constant in longitudinal direction. It's usual to have this shear force or this normal force between the members for a composite beam. That's usually shear force affine. I switch on the shear forces in VZ. Now you can see the force in longitudinal direction is shear force affine. Okay, that should be all for that question. Stefan, you can. I hand over. You can continue.
Thank you, Andreas. I will continue with the next topic. So the next question is, can I generate the FE mesh of 2 or multiple objects independently? So this question arises usually if you have a big solid which can, for example, represent the ground, and then you have like a girder or a beam connecting to it, represented by surfaces, and a fine image of this very thinner surfaces regarding to the solid next to each other, because we propose that the solid mesh should be at least 4 up to 8 elements per thickness. It may of course be even finer. And if you then have like a fine mesh in here connecting to the solid body, it needs to be connected at FE mesh nodes. And if we, for example, generate the mesh without any extra setting done to it, then the mesh should have like such a most likely fine representation, because the fine mesh of the surfaces needs to be guided and direct connected to the solid in the ground. This will lead to a high statistic of 3D elements, 47,000. And now the question was if there is an option that we do not need a fine mesh of the surfaces connected to the solid. And this is possible if you go into the mesh settings. You can check the option that the independent mesh is preferred. And if you hit OK and apply, it will regenerate the mesh for you. And you can directly see that there is no need to have a very fine mesh of the solid anymore. The preset is 0.5 meter. And you can also see that the statistics will lower it from 47,000 to 2,400. So you can imagine that this is a way quicker in the calculation. And this will also give you the chance to have a better sorted mesh of the solid. There's also another setting you can do. So if you double click on the solid, you can check integrated objects. And if you go into the tab of the integrated objects, you can also decide which objects should be integrated for a dependent mesh. You can also see it in the sketch on the right. And which objects should be integrated for the independent mesh. So this or these settings will most likely allow you to have a better optimized mesh and self-calculation times. And of course the forces and the objects will still be connected with some settings in the solver and distribute the forces into the connected objects, but now without the need of a same mesh. Okay, let's go to the next example. So the next question is, what is the result beam and are there special features in its application? So the result beam should always be known, usually from our customers who are already using Offerm 5 in the history, but maybe you are new to Offerm 6 and you are asking what may be the member type of the result beam. So it's a beam without any stiffness. You can assign a cross section in order to design it later on in the add-ons. But the cross section will not put any weight or any stiffness into the model. And so it allows you to most likely sum up forces of objects. So if you activate result beam, you can jump into the next tab, which allows you to define the type. So you can hit various settings in here. You can read them in the manual if you would like to know what is the specific topic about. And then you can also define what objects you would like to include or maybe to accept from including objects. The section, as told, is mainly meant to do a later on design. So in the first model, what I would like to show you is the effective area of the result beam. So it is usually meant to be put into the center of integrated objects for this result beam. And it is used to have, of course, then a certain height. So on the left, the beam is not going to the top of all surfaces, and on the right, the beam is going to the top of all surfaces. And which forces can be integrated, it's of course only the forces in the effective area of the result beam. So if it's not long enough, you can see that the normal force, which is summed up from top to bottom, will not start with 0, but it is on the right with 0. And it will start with a value and then up to the bottom to a certain different value. So if you define a result beam, you should think about how long will it be in order to think about the effective area of the result beam. If you are curious about the integration size, you can activate this as well in the basic objects, members part, and then the check mark result beam. And of course, then it will allow you to check the member forces and also deformation of some objects. If you would like to have more values, then it is about to go into the mesh settings and the member settings, and then you can adjust the number of division for result diagrams. I have another model for you to present. So it's the result beam position. So let's go into the next model. It's like a system of a surface laying on 4 columns and some ribs. And what I would like to show you in this example is that it is important for 3 inner forces what the position of the result beam is. So if you check for the internal forces, the 3 first, normal force, shear force, and the second shear force, you can quickly see that the position of the result beam does not have any influence on the result which is displayed. But if you check on 4 moments, most likely we will only compare the bending moment into the strong axis, you can see that the result is influenced a lot by the position. And why is this the case? Usually your task is to put the result beam into the centroid of the objects you would like to take care of. So the geometrical centroid. And if you do so, you can get a moment or bending moment diagram, which looks quite okay. It is related, of course, if you have line hinges at the start or not, because the beam is, once again, to put focus on just summing up inner forces of the surface or the objects it is taking care of. So the inner forces summed up are corresponding with the stiffness or the model in behind. And if you now move it topwards or bottomwards, there is the influence of the lever arm of the normal force to the bending moment. So if you put it higher, you can see that the MY diagram will be influenced a lot. Same goes for if you put it down, because the normal force will then be multiplied with the lever arm and increase your inner forces. So please take care when using the result beam, and if you want to evaluate the forces, that you put it onto the correct position. Last but not least, the last question for today's webinar is how can I transfer support loads to another model? So I have 2 models, one which is a floor above the ground and one model which is the ground model. And usually, sometimes depending on what you would like to achieve, you simply split your structure into different files. And of course, you would like to forward the support reactions you receive in the top of your building also into the bottom part. So this was already possible, but we improved now the functionality that you also can now use the function we provided also in RFM5 already, that you can create so-called free loads. What is meant like this? If we jump into the second file, so it's the ground, you can already see that there are some question mark loads, and we now optimized or integrated another option into the load wizard, so the import support reactions wizard. Please take care that this wizard will only be shown if there is already a load case defined and if the two files are put into the same project folder in the Dlubal Center. And please take care that if you multiply the file, that you file save as under a different name, because copy and pasting in Windows Explorer will not generate a unique model ID, which is necessary because there's an improvement to Often 5 that the models are linked to each other. And this can only be done with the unique model ID. So if you check this bottom file, you can see that I already created a support reaction. So I connect the model of the floor, which is in the same project folder with a unique ID. And then I told that I would like to transfer 3 loads. So this now was added to the drop-down menu list that you do not have to assign the node numbers and the lines manually. Now you are most likely free and only bound to the geometry. And since it is now only bound and geometrical projected into a certain direction, you should think about also defining the surfaces where you would like to import the forces. So just imagine if you have a floor laying in here and also define a second surface, all these forces will penetrate into the global Z direction, whatever they can penetrate. And this may double the load if you have the same surface down below. So you would have to think that, of course, if the construct of the part is only standing on one surface, you have to disable the all check and assign these loads to the corresponding surface. If you only have one plane in each model, you do not have to think about, because then only the surface will be touched. And the last part, you also can then define only the varying distribution now, but you can tell that the connection should be manually. So you could, of course, create the own assignment to an existing load case, or you do it automatically. And usually, most times, using this function, the only Z direction will be imported. So we will do it as follows. So the question marks will begun if you hit F5, for example, to start the calculation. So it will start the calculation of the so-called mother file, so the floor. And once we achieve these results, it will transfer them into our file and then also do the static calculation in our file in order to receive the results. So once we have the results, you can most likely quickly see, now if we just don't display them, that we now have the forces being put into our floor model. So where the door is, there's nothing, and only our column forces are being introduced. And now the highest functionality increase, I think, once we have now these 3 loads, is that once you go into the floor and, for example, double the forces, which can be done in the static analysis settings. I see I've already introduced this, and now we will just lower it by a half. So if we now do not modify it, let's have a look, 42 kilonewton into the Z direction. If we disable it, hit F5, then you always have to think about that this model was not yet saved. So there's nothing told to the floor below. And if we once hit save, there should be a warning that the results will be deleted. So this is the question for the connected ground model, because now we told the program the new file has only 1 times loads. And if we jump into the ground model, you can see that there are question marks again. So of course it is now known to the link that the forces have changed. So we need to recalculate it once again. So it will once start the floor model in the background again, and it will calculate us the new values. So with this new possibility, it's most likely the closing of a gap to Often 5, but with the bigger advantage that you now have also the link that it is linked to the file which is connected, and if you change this file, then the forces will be updated automatically. So if you would not like to do it, it should be able to disconnect the generated loads from the support reaction, and also disconnect then the single loads, and then the connection will be gone. But usually, depending on how you would like to design, it's a main advantage. All right, so I am done, and I will hand back to Andreas. Thank you.
Thank you for your presentation, Stefan. An additional hint from my side, you can book your free online appointment, such as a product demonstration of our main programs, RFEM, RSTAB, our Wind, our section, or about the add-ons or a specific add-on. Just scan that QR code, or you can click on that link. You can find the PowerPoint slide on the same website where you can find the recording and the models. Yeah, in the next days, you will get an email with a link to that page. You will also get your attendee certificate. Yeah, and then you can go through the webinar again with the recording and the models as you want. Okay, that should be all, also from my side. Thank you for your attention. Thanks to Stefan for your presentation. I wish all a nice rest of the day. Bye-bye.